Hey guys, EJ here. Welcome back to another vlog. Today we're going to be discussing a new topic called Coulomb'S Law. Now before we begin, don't forget to hit that subscribe button and turn on the bell notification so you never miss an update. Now let's jump right into it. Coulomb'S Law, created by a French scientist named Charles Augustin de Coulomb, is a formula that measures the electric forces between two objects. If two objects have electrical charges Q1 and Q2, and if they are separated by a distance, or distance of separation, then Coulomb's law says that the electrical and coulombic force between these objects is F equals K Q1 Q2 over R squared. K, which is a constant that is approximately equal to 8.99 times 10 to the power of 9 Newton meters squared per Coulomb squared. When you have two charged particles, an electric force is created. If you have larger charges, the forces will be larger, and if you have smaller charges, the forces will be smaller. If you use those two ideas and add the fact that charges can repel and attract each other, you will easily understand Coulomb's law. Now, matter can be electrically charged. The charges are protons, electrons, and neutrons. Protons being positive charges, electrons being negative, and neutrons having zero electrical charges, or in other terms, neutral. Now, Coulomb's law states that like charges, that is, charges with the same sign, repel each other, while opposite charges attract. Neutral charges, on the other hand, won't interact with each other at all. Now, the important thing to remember is that the closer two charges are, the stronger the force between them. One of the key to Coulomb's law is that the charges are multiplied together, which means the signs, whether positive, negative, or neutral, also get multiplied. Let's say Q1 is positive and Q2 is also positive. Multiplying two positive charges result in a positive force. And when a force is positive, it means repulsive, pushing the charges away from each other. Now let's say Q1 is negative and Q2 is also negative. This would result in a positive force. So again, Q1 and Q2 would repel. If one of the charges is positive and the other is negative, then the force would result to a negative force, meaning the charges would attract. And finally, if one of the charges is deemed neutral, the forces between them is zero. So multiplying the charges is one key to Coulomb's law. Now, here's a sample problem to help better understand how to solve using Coulomb's law. Two charges are separated by a radius of 29 centimeters. Determine the electrostatic force if the two charges are 30 coulombs and negative 12 coulombs. Now, the given are, for distance, 29 centimeters. Converted to meters, it will be 0.29 meters. For Q1 and Q2, or the electrical charges, we have 30 coulombs and negative 12 coulombs. For the constant, it's 8.99 times 10 to the power of 9 Newton meters squared per Coulomb squared. We will determine the electrostatic force. Start off with the Coulomb's law formula. F equals K Q1 Q2 over R squared. Substitute the given to the formula. It will be F equals 8 times 99 times 10 to the power of 9 Newton meters squared per Coulomb squared times 30 coulombs times negative 12 coulombs all over 0.29 meters squared. Use a calculator to determine the answer, and we would get F equals negative 3.85 times 10 to the power of 13 newtons. This is the final answer for the electrostatic force. Coulomb's law is one of the most basic ideas of electricity in physics. The law looks at the forces created between two charged objects. As distance increases, the force and electric fields decrease. Thank you for taking the time to listen. This has been AJ, and I'll see you in the next vlog. Bye!